Hello dear viewers, welcome to my channel. Today's discussions and introductions to graph theory. Okay, so we need to know what is graph theory and what is the importance of graph theory. Okay, so in this case we can say what is the simplest definitions of a graph for someone who knows nothing about the field. What could tell you is that you can think of a graph as a network. Okay, network that helps define and visualize relationship between various components. So various component. Now I will show one examples. You will see I am drawing this one examples. In these examples, the circles that you see represents the component and the lines connecting them can be thought of and signifying a relationship between the components. This idea of course have more formal names in graph theory. We refer to these circles as vertices or nodes, and the relationship is signified by connecting lines represent what we call edges. In a graph theory is all about the study of the properties of these types of network and how they can be used to model and solve a whole host of interesting problems. Okay, now I want to discuss the definition of graph theory in mathematical terms. V is a mathematical structure consisting of two sets V and E, where V is non-empty set of vertices and capital E is non-empty set of edges. Okay friends, this is the mathematical definitions of the graph. Okay, so I show some example of the graph now. Now you will check that there is some the vertices in the graph and another is corresponding the vertices we see edges. Okay, a V and E. Okay, so this is the graph and this is the example of graph. You see V1, V2, V3, V4 are the vertices, E1, E2, E3, E4 and E5 are the edges. So graph can be written as vertices with the help of edges. Okay, in another graph you see V1 and V2 are two vertices and U1 is the edges. So in mathematically graph can be written as G equals to G V comma E. Okay, now I will give some example of the graphs you need to know, that is the trivial, null graph, etc. So G equals to GVE. Now trivial graph, only one vertex, no edge. Null graph, n vertex, no edge. So a graph consisting of only one vertex and no edge is called trivial graph. A graph consisting n vertices and no edges is called null graph. Now I discuss directed graph and undirected graph. Directed graph I will draw also consists direction of edges. Graph consists direction. In this example you see V1, V2, V3 both have edges and with direction. And next graph is undirected graph. Undirected graph does not consist of edges. Okay, does not consist of edges. So I will draw a example. Okay, this is my I am drawing, and you see that v1, v2, v3 both are a directed graph, does not consist of edge. That means e1, e2 and e3 both are edge, and v1, v2, v3 both are vertices. Now friends, I will discuss self loop. Okay, self loop. Self loop, an edge which start and end at same vertex, is called self loop. In this diagram, you will see I am showing one example. You see that self loop, where you can get self loop at the edge of it is the edge is e6. E6 is self loop edge, and I v1, v2, v1, e1, v2, v3, all the edge. I am just writing all the edges and vertices. So you see that v1, v2, v3 and v4, e1, e2, e3, e4 and e5 both are e1, both are edges and vertices, and self loop is only e6. Okay, okay friends, and now I discuss proper edge and multi edge. Okay, an edge, proper edge, an edge which is not, which has, which does not have any self loop. Okay, so proper edge means no self loop. And multi edge, when two edges in a graph have identical endpoints are called multi edge. Okay, so identical endpoints. Now I will show what is the meaning of the multi edge with the example. You see that v3 and v2 both are identical edge, identical endpoint, and you see there are the two identical edge. So this is the multi edge. You see the one of the example of the multi edge. Now I write it in English language that two edges a graph have identical endpoints are called multi edge. So two edges in a graph have identical endpoints. Okay, now I will discuss another topic, that is graph. I will classify graph. Classification of graph. Graph is divided into three type. One is simple graph, multigraph and pseudograph. Simple graph, no self loop and no multi edge. Another is multigraph, no self loop but multi edges. And pseudograph contains self loop and multi edge. So no self loop and multi. Okay, pseudograph contain both self loop and multi edge both. Now friends, I discuss in incidence and adjacency of the graph theory. Okay, so let's start to discuss what is incidence and adjacency. Okay, adjacency. If two vertices in graph are connected by an edge, okay, and incidence, two edges are called incident. Okay, two vertices in a graph are connected by an edge, and two edges are called incident. Two edges are called incident if they share vertex. Okay, so now I have to told you that edge in incidence there is another is vertex edge incidence. This definition is the vertex edge incidence. Okay, another is edge in incidence, two edges. Okay, this is the edge incidence, and vertex edge incidence is a vertex and an edge are incident if the vertex is one of the two vertices that the edges connects. Okay, so you have understood there is incidents are two types. Now friends, I discuss adjacence adjacence matrix. This is the very important for a graph theory. What is adjacence matrix and adjacency matrix is a square matrix used to represent a finite graph where the element at row I and column j indicates if the edge exists between vertex or vertex j. For the unweighted graph, 1 signifies an edge and 0 signifies no edge. For a weighted graph, the matrix element stores the weight of the edge if if 1 exists or 0 otherwise. Adjacency matrices are essential for analyzing and manipulating graph structures in computer science and graph theory. So now whatever I have already told, unweighted graphs and weighted graphs. In this video I discuss a unweighted graph. You see there is 0, 1, 3 and 2, and now you see there is a no self loop. So in this case 0 is, now I am just creating the diagram total for your better understanding. Okay, and now I think that I finished my I complete my total matrix. No, it is not completed. Okay, let's see, let's check. Okay, in case of 0 there is a no self loop, so there is no edge, so 0 to 0 is 0, but 0 and 1 there is a loop, so there is 1, and 1 and 0 there is edge 1, so it is 1, because I already told that 1 signifies an edge. Okay, there is an edge, and 0 and 1 there is edge, 0 and 2 no edge, and 0 and 3 no edge, and 1 and 1 there is a no edge because no self loop, and 2 and 1 there is 1, and 3 and 1 0, 2 and 0 there is 0, 2 and 1 there is a edge, there is the 1, so 1 2 and 2 there is an edge 1, and 2 and 2 there is no self loop, so it is 0, and 2 and 3 there is an edge, and similarly you see 3 has only one edge, 3 to 2 connection, so it is 1, because I hope that this is same like a Markov chain. If you watch my Markov